Okay, so we're going to draw 1, 2, 3, 4, 5 different atoms today. And if you look at lithium, and if y'all can look at lithium on your periodic table while we do this, you notice that he's in group 1, which is our columns. He's in period 2, which goes to the left, or to the right, I guess. So the groups go down, the periods go to the right. So the periods are the rows, groups are the columns. Now, the periodic table is arranged by increasing or decreasing reactivity, which means the groups on the left-hand side are more reactive than the stuff on the right-hand side. There is one exception, group 17, which is very reactive. And the reason we need to know how to draw atoms is because the electrons in the outer ring are what makes them reactive or less reactive. And so if we know how to draw them, we have a better understanding of why they're reactive and why maybe certain atoms will bond or come together with other atoms. So it's really important. This is really basic to chemistry, and so it's kind of like adding and subtracting. If you can't do those things, you can't divide and multiply. So it's kind of like the basics of chemistry is being able to use the periodic table. And so we got to know what each one of these things are telling us. So this first number at the top is called the atomic number. And the atomic number is going to tell us two things of that atom. It's going to tell us protons, which are positive, and as long as our atom is neutral, that means that it has no charge, then it will also tell us the electrons. And both of those particles are called subatomic particles, means they make up the atom. And the reason why that number tells us the protons and electrons is because when they equal each other, they cancel each other out. So the way to think about this is when you have 3 plus things and 3 negative things, if you add those together, 3 minus 3, you end up with 0. And so when we're dealing with atoms that haven't undergone a reaction, then we're talking about atoms that have no charge. And so the 3 will tell me protons and electrons. Now there's one important thing we have to remember, and that is that the electrons can change when they go through reactions. We can get extra electrons or lose electrons in the process of reaction. But the protons will never change. So that's one important thing that we have to remember is that as long as we know the protons, we can identify what the atom is. So only lithium atoms have 3 protons. All other atoms in the periodic table have different numbers of protons. So there's only 3 subatomic particles: protons, electrons, and neutrons. And when we're talking about the mass of an atom, because this is our mass right here, the mass is only what's in the nucleus. And hopefully we know by now that in the nucleus there's only 2 things. There's protons and neutrons. And those 2 subatomic particles are the same size. Now electrons are itty-bitty compared to the atom. Electrons, it would take over 1,800 electrons to equal just 1 proton or just 1 neutron. So in the mass we don't even use the electrons to calculate their mass. So if we know that whatever is here is what's in the nucleus, and we know the protons, then if we can subtract this number from this number, what would be left over would be the neutrons. Now the problem is that this number is a decimal point, 6.941. Now that means that there are different variations of this atom. They're called isotopes, which means that certain atoms have extra or fewer neutrons than the more common form. And so that's not so important to understand right now. All we need to know at the moment is that the most common atom of lithium has an average mass of 6.941. So what we would do is round this number, so 6.9 becomes 7. So we round 6.9 to 7. And so anytime this number beside the decimal point is 5 or higher, we round the whole number up. If it is lower than 0.5, so if it's 0.4, 3, 2, 1, or 0, then we just keep it the whole number. But because it's 0.9, we're going to round the number to 7. Now remember, once we do that, we're saying that the average atom of lithium weighs 7 AMU. And AMU means atomic mass unit. Okay, now remember that number is containing both protons and neutrons. Well, we know the protons are 3. So if we subtract the 3 protons, then whatever is left will be neutrons. So 7 minus 3 is 4 neutrons. Okay, so we have 4 neutrons. Okay, so now we're left with the period, the row, the row that they're in. So period 2, when we look at the periodic table, if we were to draw a simplistic periodic table, we have two groups right here, and we have them divided. Actually, this wouldn't be here. This would be hydrogen. And then we have this row right here that has lithium, and I think the other one is it beryllium? What's right next to that? Let's take a look. Yeah, beryllium is right here. And then if we come across, then we get into group 13 that comes over, and we got boron and so on. This would be group 1. This would be, period 1. This would be period 2. So all the atoms in this row have two rings in them. Okay? The groups go down. So we're in the first group on the left-hand side, so that's group 1. Okay? So what does that tell me? What about the atom? It tells me, this one tells me the rings, energy rings. And this number will tell me the valence electrons. And valence electrons are really important because that's really what we want to know about the atom, is how many are in the outer ring so that we know how the atom will behave. So now we have everything we need to draw this atom. We know that we have a nucleus, so the very center of the atom. And it's going to have the protons and the neutrons. So the protons will be 3. And the neutrons will be 4. And they don't have a charge. Neutrons are the same mass as a proton, and they don't have any charge at all. So really all they do is contribute to the mass of that atom. I've been told that it's kind of like glue that holds the protons in place. Okay? Now, around the nucleus are the energy rings of the atom. And we said that the period 2 tells me how many rings. So I'm going to draw 2 rings. 1, 2. Now, we've got to remember that these atoms are very, very small. In fact, just a little period at the end of a sentence has over 1 million atoms in it. And so when we squeeze this thing down, those rings get closer and closer to the nucleus, even though in reality they're kind of distant, because most of the volume of an atom is empty space, so there's really some distance here. But because these are really, really small, the first ring can only hold 2 electrons. So we'll put 2 right there. Now, how many total electrons do we have? We have 3. But once this ring gets full, the next electron has to go to the next ring. So we'll put it right here. Okay, so we have 3 electrons. We have 3 protons. Remember, those had to equal each other to make it a neutral atom. We have 4 neutrons. And if we look, and we can check ourselves, because group 1 tells me that there should be only 1 electron in the outside ring, and that's true. That's the valence electron. Now, the thing about him is he's very reactive because this second ring can hold 8 electrons. Well, it would require him to go find 7 more from another atom that's willing to give them to him. It's kind of like asking a rich man or a poor man for $100. You know, he's not willing to get rid of $100 because he needs the money himself. And so he's probably going to want to get rid of this electron. So what's kind of cool about him is he's willing to give away his electrons to some nonmetals very easily. Okay? So one of the atoms that he will likely react with would be chlorine, because chlorine is in group 17. We're going to find out that they have 7 valence electrons. And if he can give that 1 electron to chlorine, it becomes lithium chloride. And what happens is this ring on the outer ring of lithium disappears, and it's like this inner ring becomes his outer ring. And it can only hold 2, so it's full. So it makes this guy really, really stable. Okay? Now let's just check ourselves again. We have period 2, which means he has 2 rings. That's right. He has 3 electrons, which we have 1, 2, 3. That's correct. We have 4 neutrons, which is correct. So everything checks on this atom. Okay? Okay, now we're to helium. And helium, if we look at our periodic table, we just did lithium, and lithium is right here. It was group 1, period 2. So now we're going to do helium, which is way over here. It's in group 18, period 1. So it's 1 row above the one we just did. Okay? So the cool thing about the way we draw atoms is everything follows the same rules pretty much. Okay? So we go through the things we know again. What does this 2 tell me? What's that 2 going to tell me? You can look back over here.
The protons.
Protons and
Electrons.
electrons, right. Okay, so we know that this atom we're going to draw has 2 protons, 2 electrons. What does the period tell me? What will the period tell me?
The neutron.
Nope. This number on the left. What row he's in?
It would tell you how many electrons.
No. Okay, if we look here, we're talking about going left to right. It's going to tell me the number of energy rings. Okay, so to find the neutrons, which you asked me about or thought that this number would tell me, remember we have to do something special with this number. This is the atomic mass, what's in the nucleus. So what do we do with that number before we do any math to it?
Round it.
We round it. So this number is 4.0 this time. So this number is less than 5 next to the decimal. So it's going to stay 4. And remember that's total protons and neutrons. Well, we know that there are 2 protons, so we're going to subtract the 2 protons. And what we're left with are 2 neutrons. Okay? Now the interesting thing is when we get to groups 13, which is right here, to groups 18, we got to ignore the 1. So when it comes to it, we just circle that 8, and that's going to tell us how many electrons are in the outer ring. Well, there's a problem with this particular atom because it only has 2 electrons. So we'll talk about why that atom in group 18 doesn't have 8. The rest do. You notice there are 1, 2, 3, 4, 5, 6 atoms in group 18. Well, helium doesn't have 8 electrons. He's only got 2. But the other ones like neon has 10, argon has 18, and krypton has 36, xenon has 54, radon has 86. See, those electrons are enough to actually fill those shells up beyond the first energy ring. And so the first ring can hold 2, the other rings can hold 8. So helium is kind of like the oddball in group 18 because it doesn't have enough electrons to go into another ring. So we'll make sure we see that here in just a second. So the first thing we're going to do is draw our nucleus. What goes in our nucleus?
The 4 proton, 4 protons.
Well, we don't have 4 protons on this one. How many protons do we have?
2.
2. So we have 2 protons. And what else goes in the nucleus of an atom? What did we say was
neutron.
There we go. So 2 neutrons. Okay, how many rings will we have on this atom? Kind of in the way.
8.
No, where did we write the word
1.
rings? 1 ring. Okay, so we'll have 1 ring. How many electrons do we have?
2.
2. And remember the first ring around the nucleus can only hold 2 electrons. So we got 1 and 2. So let's check our work. Okay, remember in group 18, helium is the one atom that this does not work with, so we're not going to use that as a check. But we do see that it has 1 ring, and that checks out. 1 ring. We have 2 protons right here in the center. That checks out. And we have 2 neutrons. That checks out. So if you notice, it's a pretty easy atom. It's a little bit not as heavy as lithium, and that makes sense because it's used in balloons, not hot air balloons, but it's used in balloons like at parties, and it actually rises, so helium balloons can float around because they're very light. They don't have very much in this nucleus, so they're lighter than other air, and so it floats up. Okay. Okay, now we're going to look at boron. All right, so following the same rule, let's look at this 5. This is the atomic number. What's it going to tell me about this atom? It tells me 2 things.
The protons and electrons.
Protons and electrons, the charged particles. Okay, what will this 2 tell me in the period?
The rings.
Good, rings. And what will I do with this number?
Round it.
Okay, round it. So it's 10.81, so what will I round it to?
11.
Good, 11. Okay, so great. And we're going to circle this 3. because the 1's not going to matter when we have 2 digits, when we're talking about those numbers. Now, one rule also, which I need to mention, is the valence electrons, that rule doesn't apply for groups 3 through 12. Those are transition metals, and they're kind of crazy. They have usually 2 or 3 electrons, and they follow a different set of rules. So in middle school, we really don't learn those. Those are really kind of reserved for high school chemistry. But we'll work with what we have here. Okay, so right now, we didn't finish this out. So what do we do after we round the number 10.8 to 11?
Subtract it by 5.
Good, subtract the 5. Because again, this is my nucleus. It's protons and neutrons. I know my protons, so if I subtract my 5 from here, I end up with 6 neutrons. Good. Okay, so now then we start off with our nucleus. What goes inside our nucleus of every atom?
Protons and neutrons.
Good. Protons, which are positive, and neutrons, which have no charge. How many protons does this atom have?
How many?
Yep.
5.
5. And how many neutrons does this atom have?
Neutrons, 5. 6.
6. How many rings will this atom have?
2.
2. So we're going to draw 2 rings. 1 and 2. Okay, now then, our first ring can hold 2 electrons. Well, we have 5, so we're going to go ahead and put 2 on this first inside ring. That's all it can hold. And the reason I'm kind of drawing them apart from each other is because they have like charges. Well, like charges repel each other. They want to push each other away. Now, the protons, which are positive, kind of keep those electrons near the center. So they kind of hold each other together in place. However, the outer electrons get a little weak because they're further away, and so they can be stripped away by other atoms, or added to, by the way. Okay, so we have a total of 5. I've got 2 electrons. How many more do I need?
How many more do you need?
Yep. I need 5 total, and I have 2 so far.
3.
I need 3 more, so I'm going to put them around here. 1, 2, and 3. Okay, now I'm going to check my work. Okay, I have 2 rings. That checks out. 1, 2. I have 5 protons in the middle. That checks out. I have 5 electrons. 1, 2, 3, 4, and 5. That checks out. And I have 3 electrons in the outer ring. The valence electrons. Those are very important. That checks out. And then I also have 6 neutrons. That checks out. So everything checks out so far. Okay, let's go over to sodium. All right, following the same rule. Okay, this 11, the atomic number. What's it tell me again?
The protons and electrons.
Protons, the positive stuff. Electrons, the negative stuff. We're in period 3, which is the row that it's in. What does that tell me about this atom?
Which
This atom, period 3. What's that period 3 tell me?
rings?
Rings. Okay, then I have this number here that is 22.990. What do I do with that number?
Subtract it.
I can't subtract it yet. What do I got to do first?
Round it.
Round it. What's 22.9 turn into?
23.
23. Okay, and so the most common form of sodium has a mass of 23. Okay, because it has isotopes, meaning there's other atoms that are not as common that are contributing to the average mass. Okay, then I know this includes both protons and neutrons, this number. I know my protons are 11, so I'm going to subtract the 11. What I'm left over with is going to be my neutrons. So in this one I have 12 neutrons. Okay, now I start with my, and also remember this number should tell me the valence electrons, the ones in the outer ring, so when I check myself. Okay, so I'm going to start with the nucleus. What's in my nucleus?
Protons and neutrons.
Protons, I'm going to draw that over here. Protons and neutrons. Okay, how many protons do I have?
11.
11. How many neutrons do I have? 12, good. How many rings should I draw?
3.
3, good. So the rings is period 3. So 1, 2, 3. And this should make sense because I have a lot of electrons compared to the other ones I've drawn, so I need more space for them to go. Okay, so the first ring can hold how many electrons?
2.
2. So I'm going to put 1, 2. Okay, now then, the next rings can hold up to 8. I have 11 total. So I'm going to go ahead and put, because 8 plus 2 would be 10. So I'm going to go ahead and fill the next ring with 8. And I'm going to pair them up because it's easier to count at this point. When the atoms get bigger, usually you put your electrons together when you draw them. That makes it easier to count. So we got 2, 4, 6, 8, 9, 10. How many total do I need?
Oh.
On electrons? Where'd you get a 12 from? Oh, you're looking here.
Oh, 11.
I need 11. So I have 10 right now. How many more do I need?
2.
11 and 2 is?
1.
There you go. 10 and, 11, and plus 1 is 11. So I'm going to put one more here. And remember, this number tells me how many is in the outer ring. There's only 1 in the outer ring. If you notice, that atom, sodium, is right below lithium, which is the atom we did let's see, we haven't done lithium. Oh, we did lithium. Yeah, lithium was the first atom we did. Remember, it has 1 in the outer ring, which means it wants to get rid of that 1. So it's very, very reactive. It's in group 1. It wants to get rid of this guy so badly that it will just give it away to anything, pretty much. And it really likes to give it away to group 17 atoms. Group 17 are some non-metals that are also very reactive. And if he gets rid of that 1, this second ring here becomes his outer ring. And you notice it's full, so he becomes stable. Okay? Right, so we'll check our atom. We have 11 protons, that checks out. We have 12 neutrons, that checks out. They're both in the nucleus. We have 1, 2, 3 rings, that checks out. And we have what else do we need? Electrons, we had 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we followed our rule. 2 in the first ring, 8 in the other rings. We don't have 8 in the last ring because that would have given us too many. He only has 11. But if it was a bigger atom, we could still continue to put 7 more in that outer ring. Okay? Okay, oxygen. Oops, I didn't write down his atomic number. It's 8. Okay, what's that 8 going to tell me about this atom?
The proton and neutrons.
Not neutrons. Just the charged stuff. Remember, neutrons aren't charged. Look back here. What's it tell me?
Electrons.
There you go, electrons. Okay, what will I do with this number right here?
Round it.
Okay, what's 15.999 round to?
6.
16. Good. 16. And what will I do with that number?
Subtract it.
Subtract this
By
atomic number
8.
by 8. So 16 minus 8 equals 8 neutrons. Okay, what's the period 2 tell me about this atom? Rings, good. I don't know why, I guess I put 8 there earlier instead of down here. He's actually in group 16. Okay, group 16. Okay, so now then, the 16 should tell me it has 6 valence electrons. We ignore the 1. Okay, so I'm going to draw my atom. What goes in the nucleus?
Proton and neutron.
Protons and neutrons. So I got a positive thing and a no charge thing. So how many protons do I have?
8.
8. How many neutrons do I have?
8.
8. Okay, how many rings should I have?
2.
2. Good. Okay, how many electrons can go on the first ring?
2.
2. Okay, well I have a total of 8 electrons. So how many more do I need?
6.
Good. So I go 1, 2, 3, 4, 5. And I'm still pairing them up just because it's easier to count and to see if it's full or not. So in the outer ring I should have 6. 2, 4, 6. That checks out. 8 protons. That checks out. 8 neutrons. That checks out. 2 rings. That checks out. And I follow my rule. 2 electrons in the first ring and up to 8 in the next rings. Okay, so very good. This one is slightly reactive. It needs 2 electrons that it would like to steal from another atom to make a compound, and it becomes stable. Oxygen is one of those interesting atoms. It's diatomic. It will never exist by itself, so it always pairs up with another atom of oxygen. And so what happens when another oxygen is made, it actually shares 2 electrons between each other, and it's called a covalent bond, and it becomes stable at that point, or more stable. It still can it causes fire to really get big and crazy, right?
Yes.
Okay, guys, so that's kind of our review of how to draw atoms.